Hello, everyone. Welcome to the EconLLMs Lab first workshop, or hopefully out of a series of workshops on prompt engineering, specifically on how to use LLMs in practice and in research. My name is Augusto Gonzalez Monorino. I'm the lead graduate researcher at the lab. And if you haven't noticed by my accent, I'm from Argentina. So, yes, we're definitely still celebrating the World Cup. Um, I'm a PhD student and a faculty at Pomona College, where I teach statistics and economics. But I also teach. I'm also coaching the tennis team this semester, so I have this interesting background, blend of backgrounds that has given me a unique opportunity to really experience the impacts of this technology across many different domains and actually interact with the people who might be benefiting from it. I have worked in NLP, in natural language processing, since 2020. When I was a junior undergraduate at Marist College, I was hired to lead a group for developing a chatbot using state-of-the-art techniques of the time. And at that moment, GPT and the transformer, all these technologies that we're going to be talking about today already existed, but they were pretty useless. We tried GPT type models, we tried all these generative AI type of models, and we ended up deciding for a different type of architecture, more deterministic type of architecture. But that has changed dramatically. There's no better language model than current LLMs, and these LLMs are based on GPT architecture as a generative AI. More specifically, AI has permeated my life in three distinct areas, of which I would group them into two. Personal research interests, which would encompass education. This is because as a student, I'm very interested in finding use cases and applications on how can I use these LLMs to make myself more productive, both for studying, both for gathering better literature, doing research literature, improving my writing, and also working with code. I have found it extremely useful, and hopefully today's workshop will give you the tools to be able to start making your own use cases. Then also in education, from the perspective of the professor, I try to encourage the usage and learning this tool in my classroom for my students because they can find, I hope, the same benefits that I've been finding. The second one is economic research tooling. This basically means I like to make tools. It's very fun. It's a very fun technology, and it ends up being very practical. Right? But it has limitations. It's not magic. And today, I'm going to be one of my goals for today is to demystify some of these magical attributes that are being attached to LLMs. And finally, we are interested, and the third one is the EconLLM lab research focus, where we want to capture latent preferences, basically by studying collective decision making in complex adaptive systems. Right. So now I'm throwing away a couple of buzzwords, but the reason why I share specifically what is our intention at the lab is because we're always open for new members. If you are listening to this and you're interested in the topics that I might mention along the way, definitely feel free to reach out to me, reach out to anyone in the lab, either for a position or to collaborate on some project if you have any ideas. Right? Because what we want to do is if we can prove that we can train LLMs somehow to capture latent preferences from participants, let's say experiment participants, then we can start developing LLM evaluation methodologies that are based on game theory and experimental economics to seek for a alternative to quantitative benchmarking, which is having so many issues nowadays in the field of LLM and specifically more general purpose technologies. Now, this is super cool stuff because if we can show that we can induce a chatbot to behave as if it had certain preferences or values, Then we can run simulated experiments to study how corruption emerges from a country's value structure or belief structure, or to reduce pilot costs for large-scale surveys. So this has some potentially very significant implications. But we're not here to talk about much about our research. Believe me, I could spend hours talking about these ideas. I think they're fascinating. So if you'd like to continue the conversation, please reach out. Let's get on to the meaty stuff. I thought it would be insightful to kick off by painting the broader picture of current approaches in the field. There are two AI paradigms which stem from different views of intelligence and the human mind. I think this recent debate from the last couple of years between two philosophers, Noam Chomsky and Peter Norvig, on the fundamental structure of language, I think it illustrates these differing ideas very well. So Noam Chomsky is a linguist, Peter Norvig is a computer scientist, and they both work in language. Chomsky argues that language is symbolic, that we need to understand the meaning of the objects that we are using to construct the text and therefore to construct language in order to claim that we are actually understanding what the language, the information that the language is communicating. But Peter Norvig says, look at all these models that we have. They're all statistical and they work pretty well. It almost looks like they actually understand what they're doing with that text. So the gap in the ideas here is Chomsky claims that our brain must process language symbolically. It has mental models and representations of what the language means and what the word means in relation to each other, while Peter Norvig claims that maybe, given the recent success of these machine learning or statistics-based algorithms, maybe our brain is just statistics. Maybe all we are doing in our head is making these correlations and kind of trying to make sense of what's happening with this language. So with these two ideas in mind, two AI paradigms emerged. On one hand, we have symbolic AI that aims to encode the meaning and the relationship of symbols to deduce information. So it's a deductive approach. On the other hand, there's statistical AI, which relies in induction, right, on inferring information from statistical information, from statistical relations computed from huge data set. So this is the first trade-off, right? For symbolic, we need a very accurate representation. It's hard to start with, but we don't need a lot of data. It's easy to interpret, right? While statistical AI or machine learning-based AI is way more flexible, it's easier to scale because we don't have these combinatorial problems, yet it's very hard to interpret, right? And it requires a lot of data. So there are advantages, disadvantages to both, but the latter has been the dominant paradigm since the advent of deep learning methods and computing power. So let's dive a little bit deeper. Within machine learning-based AI, we have two types of models. Generative models that use prior data to generate new data from learned correlations, and discriminative models, which try to learn classes or boundaries to classify new data. ChatGPT and LLMs in general are just a new cool kid in the generative AI landscape. And we're going to talk a little bit more about the details of generative AI specifically, but be aware that there's this difference. And the difference relies on the type of statistics that they use. Generative AI is a Bayesian thinker, and I'm going to come back to this idea. And discriminative AI simply relies on conditional probabilities to classify data. We're missing a key component here before we start talking about prompting, which is how do we even deal with text? There are two main components. One, some way of encoding text with numbers such that the machine can understand, right? And the second one is some way of decoding it to predict how the sequence of text will continue. This encoding is called tokenization. We want to represent text or as tokens, and there are many algorithms to create tokens. For example, backword, TF-IDF, word2vec, but they are all some variation of dictionary encoding. This means that we have some keys that are unique and some values attached to those keys. We start with a large corpus of text, which is also called a vocabulary, that is then split into words or subsets of a word, therefore generating tokens of words, which is then assigned an index number, some integer, and therefore you end up with a tokenized sequence. Then, based on these encoded tokens, a sequential neural network, for example, or some sort of architecture that is capable of handling the sequential nature of the data, is trained to predict the next token, keeping a memory of what has been processed so far. So like the recurrent neural network on the right, which depicts the prediction of the word tensor, one character at a time. And here's the main problem with traditional approaches. One character at a time. Processing one token at a time was very inefficient and caused the information about earlier tokens to be quickly lost. This is called the vanishing gradient problem, which means that we want to be able to keep some sort of trace of what has been happening in the past. That means in earlier parts of the sequence, because we know that this text, this sequence that we are feeding, has some sort of contextual meaning that we need to capture. And recurrent neural networks or convolutional neural networks, they try to capture that by keeping track of what has been processed earlier. Now, of course, since we have to process one at a time, the longer the string of the text, the higher the likelihood that the predicted next token is completely unrelated to earlier parts of the string. And this is exactly what we were seeing in earlier stages of generative models. They would start producing something that made sense, and along the way, they completely forgot the topic of conversation and then just continued to something that at least looked completely random. So the field faced a bottleneck with no clear solution in sight. There was a need to process large windows of context motivated by new approaches, and this culminated in the transformer architecture that was proposed by a group of researchers at Google in 2017. We're not going to get into the details of the transformer, but there are a couple of insights that I want us to agree on so we all have at least some idea of what's happening in the background, because this is going to give us a very good idea and concept of what the prompt is and why the prompt is so important. So the transformer takes this input sequence of tokens that we just created and then encodes some information about the position of these tokens to create vector representations or vector embeddings. Right? This position is going to be handled by a technique called positional encoding, but the basic idea is that now that we have these tokens, we want to somehow encode the information of each token relative to the tokens nearby, or all the other tokens in the sequence, such that we can manipulate it with matrix calculations. It relies completely on a technique called self-attention, hence the name of a seminal paper that introduced this architecture. It's called Attention is All You Need. So somehow, through this attention mechanism, the transformer will capture the context at once, hence eliminating this need to process tokens sequentially, which is awesome, right? Because big matrix calculation is exactly what the field learned to do very well in the last couple of years, I would say the last couple of decades, with deep learning and GPUs and all this massive parallel computing that the field has been developing. There's obviously much more going on in the background, but for the purposes of prompt engineering and therefore this workshop, all I want us to agree on is that we give it a sequence of numbers or tokens that have some contextual meaning that maybe we are aware of, which is extracted by embeddings models and used to condition on the training data to generate the most likely sequence of numbers or tokens to follow the input. Right? So sequence of tokens comes in, sequence of tokens comes out. The transformer really just allowed us to scale up sequence processing significantly. In fact, pretty much the only advance since then has been to find new ways to keep scaling it. Right? These efforts led to huge models, massive, which are now called foundational models. And this means that they're foundational for one specific type of domain because they're being trained on a massive amount of data for that specific domain. If the foundational model has been trained on a lot of text, we're going to call it a large language model. The beauty is that it seems that we can do this with any sequence. So text and even time series might be a task suitable for transformers. Actually, in fact, people are working on foundational time series models and for financial forecasting and neuroscience data, for example. So as long as if you have sequence data, as long as you have a lot of it, you can potentially leverage this technology to process that large corpus of sequential data in parallel simply by using matrix computations. Therefore, I hope this shows you that prompting, and I know we haven't talked about prompting yet, prompting goes beyond textual instructions to LLMs. It's pretty exciting. So there's a concept of a prompt, this input of sequence of tokens that just goes way beyond chatting with ChatGPT, for example. Right? We can do much more with that, and this is my motivation for introducing the prompt, both conceptually and technically. Now, let me make a caveat here because I want you to note that at no point in my description of how the model works did I reference understanding or reasoning. In general, machine learning models learn by feeding some data, right? Just akin to how babies learn by matching observations with experiences. Where the data comes from, or how was it measured, or who even is the observer attaching the meaning, right? Because meaning is subjective, is not even part of the optimization problem. Remember, LLMs are generative models, so they simply estimate probabilities of what tokens ought to follow based on available information and new evidence. There's no understanding of the concepts or the text that is being generated, which is why careful prompting and instruction is so important to elicit desired outputs. If they could understand us, right, why would we need to focus about why would we need to worry about writing good prompts? They should just be able to understand us. And if you take a look at the right, I have two examples of how these models work in the background. Right? We don't care about the transformer right now. All we know in this visualization is that we're creating an input text, weights and biases, machine learning. Boop. This is getting tokenized, which just assigns some index and integers to encode where they are in the sequence. Then somehow this black box of the LLM is going to embed this, extract the context, and all of this, and it's going to output probabilities of which word is the most likely one to follow. And you can see that as the input text grows, the output changes. And that's how the LLM is going to generate these predictions, by being greedy, by choosing the word that has the highest likelihood of following this specific sequence. Great. So now we're ready to finally start talking about prompting. Let me start with a definition of what prompt engineering is. It is the process of structuring text such that it can be interpreted by a generative AI model to elicit desired outputs. A prompt is natural language text, often fed to a foundational type AI model describing the task that an AI should perform. This means that you don't need to be a programmer or an AI scientist to be good at instructing LLMs. But this is the whole idea, right? This is the whole innovation here. Up until now, we could only interact with computers via programming languages and coded instructions. So you needed to know various types of programming languages to be able to have the computer do whatever you wanted. This has clear entry barriers for people that are not very technical savvy. But now these models, computers, are starting to learn how to read instructions from natural language text, which opens opportunities for many other individuals to start working and generating content with computers. But, okay, so that seems very simple, right? If it's just writing some text, then what makes it engineering, right? There has to be something else besides these soft skills like having critical thinking, being able to articulate your thoughts, to carefully write a set of instructions, and being a subject matter expert. The short answer is tuning. We will never be satisfied with the first prompt that we craft, regardless of how effective it is. We need to go through the engineering cycle of building, testing, redesigning. It plays a crucial role in this, what I'm going to call a nascent field. Pretty new. But it also implies tracking. We want to keep a record, maybe a Google Docs, a text file, or just a Python script. Can be as simple as you want. But we want to keep a record of the prompts that have worked in the past, because you will most likely find use cases to reuse, recycle them, or at least improve upon them. And this is crucial, especially if you're trying to build LLM-based applications using models that you haven't created. So third-party models like OpenAI's GPTs or Amazon's Claude or whatever, Google's Gemini. Today, my goal is to illustrate the difference between simply chatting with GPT and actually working with GPT. You will see, I hope, that it takes more effort than it is often perceived, and that it is way more of a collaboration rather than just a delegation of tasks. Through prompt engineering, we can unlock new use cases and increase personal productivity to free up time for more rewarding endeavors. Yet, while all of this may feel like magic, right? I was just giving some text to LLM and somehow is producing all this wonderful output for me. There's a particular property of these language models that makes prompting possible in the first place. And this is in-context learning. The model's ability to temporarily adapt based on prompts. This is often called an emergent property of language models, and it's emergent just because the researchers who created these architectures had no idea. They were not expecting models to be able to have this property of learning from simple interactions with the user without having to do any permanent changes. Right? There's no need to train, to further fine-tune, to update the weights, to do any sort of technical changes to the model in order to tune its behavior to your purposes. It allows them to learn on the fly, right, without permanent changes. This is the key. So in-context learning is, in that sense, the magic behind prompt engineering, because it eliminates the need for costly fine-tuning or even further training. Now, this is the general concept of a prompt, and this is what makes it engineering. And today we're going to start developing some of these tools, some of these mental models to be able to structure prompts in Python, keeping track of them, having a clear structure, and using variables to be able to dynamically program each of these strings that we're going to use. But first, I want to give you two mental models to how to think about prompting that I found useful, because like any good craftsman, we need to develop a mental model to help us figure out what to expect from a given prompt. Right? If we don't have an expectation of what the output of the model should be or how it should look like, then we will not be able to write a good prompt, because we need that detail to be able to guide the model through its reasoning. Now, from my experience, I found two perspectives very helpful for thinking about prompting. One is I'm going to call it the conceptual model, and this is where my tennis experience, or at least teaching background, plays a role. For example, imagine you're explaining a complex task, something complicated, to a child who is brilliant or some very well-behaved soldier who just follows rules meticulously. If your instructions are too vague or abstract, the child might get lost. The soldier might follow your instructions to the foot, and it might yield an undesirable output simply because the instructions were not well structured, they were not well articulated. But if you're precise and clear, they will excel. So here's a tennis reference. When we're teaching how to hit a tennis forehand, or really any topic, to someone that recently started playing, it is just futile to use all the technical terms that he or she might not even know, right? You're just going to confuse them more. There are language barriers. So as a coach or an educator in general, our goal is to break down the message into clear and direct instructions that use concepts that they are familiar with, right? We need to put ourselves in their shoes. We are the subject matter experts in this case. For example, it is common to teach the forehand to little kids as you're going to draw a C in the air, then come full circle to extend your arm straight forward, and then finish by putting on a scarf. All right, so instead of simply instructing them to go hit forehands and using all these technical terms, we can just instruct them to go draw C's and put their scarves on. This way we can get even little kids to actually follow instructions. Otherwise, just hit a forehand ends up with everybody hitting each other with their rackets. Complete chaos is not a useful response. Similarly, crafting a clear and well-structured prompt ensures that the LLM produces useful responses. Obviously, this is not how you would teach a professional how to hit a tennis forehand, which is why if you have a highly fine-tuned model for a specific domain use case, then you can abstract away all these requirements or demands on the quality of the prompt. The second type of mental model, which is the one I'm more keen towards, is a statistical mental model. And for this, I want you to think Bayesian, because LLM, as we claimed in the first slide, they are generative AI models, and they're based on Bayesian statistics. They're trying to compute posterior probabilities. So LLM generate new data. This is the output text, based on their training, which is an exposure to a large text corpus or vocabulary, given an input, which is going to be the sequence of input tokens. So they have some prior knowledge. This is their training data and the model's baseline understanding of language before any specific input or task is given. Then we can introduce some sort of likelihood, right? Some new evidence that we want the model to take into account in order to pull information from its training data to then compute the posterior likelihood, which will represent the model's response or prediction given its prior knowledge and the current evidence. And this current evidence will be our prompt. Okay, so this is another way you can think of it, either as a careful and clear breakdown of instructions of how to go about doing a task, or as introducing new evidence that will condition the model to look at the specific context that we want it to look at in its training data. Great, so with that, we can move on to actually getting our hands dirty and start working on some of these prompts. So if you haven't, here's the QR code to go to the Python notebook, but it will also be attached when this video is released. So let's go. The goal for this Python notebook is, first, I'm going to start with a review. I'm not sure your level or the average level of Python knowledge in the audience. So I want to start with a little review of strings and how to manipulate and format strings in Python, because this is going to be our primary tool for engineering prompts. So remember, we can use double quotes, single quotes, or even triple quotes to define a string in Python. So for example, here I'm defining 3 different strings, and I can print them out just like this. And the reason why this is useful is because we can combine different types of quotes to account for apostrophes, for example, right? If we want to use an apostrophe here, and we're using single quotes to define the string, then Python thinks that the string ends where the apostrophe is being placed, which is not what we want. But if we place the apostrophe within a double quote, within a string that is enclosed in double quotes, then it will actually interpret it as a string, as you can see here, without giving us an error. We can concatenate strings by simply using the sum operator. Here I'm concatenating the first string with the second string and get this result. And here I'm concatenating the first string plus some white space plus the second string again. We can define new strings and we can index them to get a particular subset of that string. So for example, I can get the first 10 characters of my string, welcome to. But what if I want to get, what if I'm interested in extracting a specific keyword that I know is in this text? For example, when we start working about prompt engineering, you will most likely want the model to output its response in a very specific structure. Maybe it's just a one-word response, maybe it's a sentence-long response for where you're looking for a specific keyword in that response. And it's useful to be able to use Python to find it. So here I'm defining a substring to be EconLLM. I want to find where EconLLM, the word, is in this new string. And for that, I can use the method find. So .find, we pass it in the substring, it will return the ID, the index in the string in which this word starts. And from there, I can combine the ID and indexing to actually extract specifically that keyword. And here we can see it. We're just printing out EconLLM from the string. We can also split a sequence of text, a string, into components or into words by using this split method and passing in a character at which we want to split this string. So for example, if we use the same new string example that we're using here, and we split it in all the white spaces, then I'm going to get a list in return that has all the individual words that are separated within the space in the string to create this list of words. Now, we have a sequence of individual words or subsets of words, which we can now tokenize. This is why I'm showing you these specific methods. There's a reasoning for all of this. But we can also join them. And we are given a list of words, a list of tokens that maybe we want to decode, and then we have a list of strings. We would like all of those strings to be combined into one single string. We can use the join method to combine all the elements of that list based on some specific separator that we're interested in. This could be a white space, it could be hyphen like in this case. We can also use white space and we get back basically the same string that we had before. We can also set everything to lowercase or everything to uppercase, and we can format strings. And this is going to be the first key takeaway of this workshop. F-string formatting is your best friend. F-string formatting is the following. We start with the keyword F and then define our string, however we want it, single quotes, double quotes, triple quotes. What this F formatting allows us to do is to pass in variables within the string. And once we pass in variables whose values can change, now we are working with dynamic strings. This is what we're going to call a dynamic string, because the ultimate value of the string will depend on the value of the variable or variables. In this case, I'm saying welcome and then print whatever the value of the name is. If I change it from Augusto to Juan, it will change immediately. We can also use numbers here, right? 5 plus 10 is, and then we do some mathematical operation using Python. It is not this other mathematical operation. We can format numbers. Here, if we import pi, I can print out pi to 3 decimal places. And this is the return, this is the output that I get back. I can also do it for dictionaries, lists. I can get more and more complicated. And this is where I'm going to go a little bit faster because I want you to play around with this. If you're not comfortable with these different basic data structures in Python, then definitely go around and play with them. Here, what I'm saying is the name of this person is going to be whatever value the key name in this dictionary called person has, and the age is going to be the value of the key age in this dictionary. So this will yield the name is Eric and his age is 30. We can do the same thing for lists, right? Here's the first fruit is apple and the last one is cherry. We're just using indexing here. We can also do some more cool stuff like using datetime to print out today's time or today's date. If we call this now, it should get updated to 6th of March, which is when I'm recording this workshop. And we can use F formatting to put all of that together, right? In this case, we're not just indexing or passing a specific value, we're actually calling a function and printing out the value of that function. And we can also extend this idea to creating profiles, right? What I'm calling multi-line F strings here. I have 3 variables, and I want to use the values of these variables to create a profile in a very specifically structured manner. And this is what I get as an output. This is the key idea. This is exactly what we're going to keep using and reusing and iterating over to try to find the values of the variables that give us the best output from the LLM. So let's apply these techniques to create our first prompt. I'm going to define 5 variables, some username, a task, a source language, and a target language, because I want to create a prompt for translating some given text from English to French. And this text is going to be hello world. Now I use f-string formatting to create my prompt, which says, hi, whatever username, your task is to conduct this task, the following sentence from the source language to this target language, and here is the sentence you need to translate. So if I print this out, I'm going to copy it. I'm going to go ahead to ChatGPT, pass it in. I'm going to delete this. We don't need to tell ChatGPT that he's Jane Doe. Let's see what he outputs. The translation of hello world in French is bonjour monde. Okay, so it only solved the task that we asked it to solve. There's no additional text, there's no hallucinations. We had a very clear and direct task, a very clear and straightforward prompt, and the output was very clear and straightforward. This is what we aim, this is our goal with this prompting, to have an idea of what we were expecting from the LLM, and then from the prompt actually eliciting that desired behavior. So play around with this F formatting, play around building different types of strings. And once you get comfortable with string formatting, you'll be fine to work with prompt engineering. So with that being said, let's go into prompting. There's 2 types of prompting techniques. One is called zero shot, the other one is called few shot. And this shot relates to the examples that we show it about how to go about solving this specific task. Zero shot prompting involves asking the model to perform a task without any example, right? The prompt must be completely self-contained, has to be clear, and the task has to be very direct. You need to provide all necessary instructions within it. So this is another emergent behavior, because these foundational models have been trained on so much text, so many different tasks already, that some of these, the most common ones, the most simple ones, are already embedded in the model's capabilities without having to give it too much information about how to go about solving it. And some of these recommended tasks are sentiment analysis, text classification, name entity recognition, summarizing text, language translation like we just did, and also just continuing a given piece of text, which is called text completion. So let's start working with this. We're going to define a very specific structure for our prompts. In this case, the structure will be a task description, which will contain the text that describes the task to be accomplished by the LLM. And then some text to analyze, because usually the task will involve manipulating some text. So these are the 2 components of our prompt: the task and the target text to analyze. In this case, I'm saying, determine the sentiment of the following text. I had a wonderful experience at the restaurant, the service was fantastic, and the food delicious. And using f-string formatting, we build our prompt. Notice the specific structure. We start with the task description, we make some space, we pass in the text that we want to analyze, and finally, we end up with a keyword that tells the LLM what is it that we are expecting. In this case, since the task is sentiment analysis, we're expecting some sort of sentiment back. This could be a score, this could be a keyword. We can control that, but basically, at the end of the day, we want sentiment back. So we're going to do the same exercise. Copy this. Let's go to ChatGPT. Let's start a new chat. Oops. If I can get to copy this. Sorry about that. Let's run it. And it outputs the sentiment of the text is positive. Right? I think it's pretty trivial. It is obviously positive. This customer was very, very happy with the service at the restaurant, with his experience. But the model is able to capture that positive sentiment. Now, maybe we would like to get something different. Maybe we have specific categories of sentiment to which we would like the output of the LLM to map to. So let's try to write a different description, just with a little more detail now. I'm going to start exactly the same, determine the sentiment of the following text. And now I'm using this, what I'm going to call a signal token. This is akin to a variable. We want to give a name to the specific text that we want to analyze, such that if the prompt or the context gets too long, we have a name that we can specifically and directly refer to during the classification process in this case. Now I'm going to continue my description by saying consider the sentiments satisfied, dissatisfied, and content, and provide a one-sentence explanation for your classification. So this way, I'm trying to debug, I'm trying to understand what's happening in the background for the model to output a specific type of sentiment score. And I'm going to use the same review. And notice that the prompt, the structure of the prompt does not change. All I'm doing is I change the description, and therefore I'm changing the variable in this first component of the prompt. Let's print this out, and let's do the same thing again. Now we get a much better output. The sentiment is he was satisfied, and the explanation is that the text expresses satisfaction with the experience at the restaurant, highlighting the wonderful service and delicious food. This is exactly what we're expecting, right? But we were able to capture much more information by adding just a little bit more information to our prompt, by being more detailed and carefully articulated. Let's go on to try another task. Here, we're going to try summarization. And what I'm doing here is, sorry, I go crazy. The goal here is, given a piece of text that is most likely too long for you to read, we would like the LLM to extract the most useful pieces of information from that text and summarize it for us. So what I did here is, as an economist, we're supposed to be up to date with whatever the Fed is doing and all the economic things that are happening in the economy. And I only say allegedly because it's hard to keep up since things are changing all the time. So it would be great if, instead of having to read all these articles by myself, I can just parse through a bunch of them really quickly and get a general idea of what people are talking about, what are the decisions that the Fed is considering and whatnot. So I came over here and I grabbed the entire text, I copied that, and I pasted it just as is to my Python notebook. And this is the result, right? This is the output, this is the text of that article. This becomes my text to analyze, and therefore the text description is generate a coherent and concise summary of the following text. And note that the zero-shot prompt does not change its structure. We have the task description, the text to analyze, and a keyword related to the type of output that we're expecting. In the previous example, we were expecting a sentiment. Now we're expecting a summary. Therefore, the keyword changes accordingly. We're going to print that out. Do the same thing here. Copy the entire string. Let's go back to ChatGPT and paste it just as is. And here we get a one-paragraph response, a one-paragraph summary of what this article is all about. Right? The Fed raised its key interest rate for the 11th time in 17 months to combat inflation, and then I can keep reading this and just get a very general idea. If I find it very interesting and there's something that I don't understand, I can go back to the original article and actually read the whole thing. But at least here, this is like reading the abstract and the conclusion of a research paper without to avoid the need of having to read the entire thing if the conclusions or the main idea is not that interesting to you. Very good. Now, here at the in-person workshop, we will stop and I will give you a couple of minutes to work through these zero-shot prompts. So I encourage you to pause the video actually and just work through this. Use F-string formatting, create your own prompts, just change the task descriptions and the text to analyze that we already been working with to get used to this idea of creating dynamic strings based on the values of specific variables. And the second exercise would be to write a prompt to translate language. And this can be very simple. So here's my solution to that. I'm going to test it out. My task description is simply translate the following English sentences to French. And the text is welcome to the EconLLM prompt engineering workshop. And now I'm using the same structure. All this changing is this last keyword here because now I'm expecting a translation. Let's go back, new tab. Now we get bienvenue à l'atelier de Ginny de prompt EconLLM. All right, we're gonna assume that's correct. That's a correct translation. Okay, this is fine. But very simple. There's no additional context, right? This is just a translation and it's done. There's no tokens being wasted here. So what do we learn? Let's recap a little bit some of the best practices. And this goes back to this conceptual mental model. We need to be explicit, right? The task has to be clearly stated, has to be simply stated. The more specific you are about what you want, the better the model can generate the desired output. The instructions need to be clear, straightforward, and unambiguous. If you start using a lot of technical jargon, then there's a higher likelihood the model does not understand exactly what these keywords are meant to mean. Just like the naive or the amateur tennis player who just does not know all the intricacies of the sport, therefore you cannot use all the technical jargon that you might want to use with a professional. You need to consider the model's capabilities. At this point, once you start playing more and more with these models, you'll find out there's a plethora of models. A lot of these are open source now, so you can play with them for free. But the key insight here is that the larger the model, the more capabilities, specifically the more zero-shot capabilities it might have. And finally, remember that we're doing engineering. You need to test and iterate. This just means that you need to experiment with different formulations of your prompt to find out what works best for your specific task. And remember to keep track. Keep track of all the prompts that you've tried, because sometimes, especially if you're depending on a third-party provider for the LLMs, if they update their model, then the model is going to update its behavior. Therefore, your prompts are going to work differently. So if there's an update to, let's say, GPT, you would love to have access to your previous prompts because maybe the previous ones now work better than the current one, than the current best solution. This is great. Now, if we want to accomplish more complicated tasks, maybe tasks that require some minimal reasoning, LLMs are not able to do so without any examples. So this is where few-shot prompting comes in. This method basically leverages or relies on in-context learning, this magical property that we were discussing in the slides, which is a new term that refers to this capacity to learn how to approach a task without the need to fine-tune it, without the need to mess around with the weights. So naturally, there's a trade-off between accuracy for loss of generality, since the prompt effectively tunes the model for solving a specific task in a specific manner. So therefore, a key best practice will be to keep your prompts and keep your task domain-specific, because the examples should be structured and domain-specific. And some recommended applications for this are documented in the literature are complex text generation. For example, any sort of text that needs a specific style or structure, such as poetry or technical reports. You can create educational content like quizzes, problem, and this is really where I found most of the interesting applications in education, because you can augment or enhance the lecture notes of your professors, or you can, as a professor, create new assignments or new homeworks based on previous ones without having to actually just copy and paste and completely reuse previous assignments, which have their limitations. And finally, language translation with some jargon, right? Or sentiment analysis with some specific examples. This is exactly where we're going to start. Our first example of a future prompt will be a more complex sentiment analysis type of task. For this, our prompt structure will have three parts. A task description, which starts with the task to be achieved, identify the aspects of the class that students liked and disliked. This is some sort of sentiment analysis, but it's much more complicated because I'm not just asking for positive, negative, or some sort of score from 0 to 7. I'm asking for specific information within this text, which are going to be anonymous class evaluations. And here I pass in the structure of the output that I'm looking for. I'm going to have an evaluation. I really enjoy the hands-on activities in class, blah, blah. And then this is my manual solution. What the student liked from this evaluation is the hands-on activities and that the professor was approachable, but they disliked the dense readings and the exams were challenging. Not that I have my baseline example. I want to add more examples how to go about doing this specific task for different types of evaluation forms or different types of inputs. And this is the second part of our future prompt. It's going to be a list of examples, which are usually simply encoded as tuples in Python. And note that these examples are all exactly the same structure. I have my evaluation form, and then I have the information that has been extracted, what they liked and what they disliked. Again, and I repeat this for 3 examples in this case. And finally, I have a new evaluation. So this is the last thing of my prompt, the third component of the prompt. It's going to be this new problem, this new evaluation to classify. And in this case, the evaluation is the class was very disorganized and the professor was often unprepared. The readings were also not very helpful. However, I did learn a few new things and made some friends in the class. To structure this prompt with F-string formatting, we're going to use 2 concepts that we cover in the review. The join and a list of F-formatted strings. And the reason why we need to use join is because these examples come in the form of a list. It's a specific data structure over which we have to loop over to extract all the examples. There are different ways of doing this, but this using list comprehension, F-string formatting, and finally the join method is the most straightforward one, because this will give us the example string for which that will allow us to reuse the same zero-shot prompt structure with minimal changes to it. What do I mean by that? We start with the task description. Now we have the string of examples, which we just concatenated in this line right here. And finally, the keyword of what we're expecting. The evaluation, we're passing the new evaluation to be analyzed. This would be our text to analyze. And finally, the first keyword to help the model start off. And remember here, the sentiment always starts with what the students liked. So this is what we're going to do here. We're going to pass in liked. Let me add one more of this. Let's print this out, and this is what we get in return. This is our first string. This is what the variable called task description. And then we have concatenated. We've had concatenated all 3 examples that we have in this list into one single string. We appended to this string to combine the task description, the examples, and the final evaluation input, the final evaluation form, to be able to create our few-shot prompt. We're going to do the same thing. Let's go back to ChatGPT, create a new chat, paste in this prompt, and see what it returns. It liked that it learned a few things and made some friends, and it disliked the class was disorganized, the professor was unprepared, and the readings were not very helpful. So overall, a pretty, bad review. But we were able to learn way more information than simply stating, hey, just give me if this review was positive or negative, or give me a number. We're now extracting information by relying on this capability of LLMs to understand the sentiment to some degree of these words. This could be very useful if you're working with survey data, for example, or with a lot of evaluation forms or customer reviews that you want to parse over, right? If you need going one by one, even if you're using some sort of ChatGPT, it's going to be very tedious. But if you have a couple of examples that you work through manually, just 3 or 4, like in this case, and then you run a loop to update, let's go back to Python, to update this specific string, the last one, with the new evaluation that you're trying to analyze, now we can parse through all of these different evaluations, different reviews, or different survey responses automatically. And this is where the engineering part, and this is why Python comes in so clutch. We're going to work through 2 more, but now I want to show you how to run ChatGPT or any of these GPT type of models from the terminal, from Python itself, because developing the prompt here and then having to paste it into ChatGPT's interface is pretty annoying, right? We waste a lot of time there. But before we get into that, let me recap some best practices for writing feature prompts. This means the examples need to be relevant and they need to be carefully structured. The structure should be consistent. The examples should be diverse and show different potential sources of input. The instructions should be clear. There should be no ambiguities, right? Just like in the zero shot prompt. This is a general best practice. And also use placeholders. This is what I call my signal token, right? The name for the text you're referring to in the prompt. Just give it a name. Just use a placeholder to allow the model to map exactly what you're referring to, exactly what's the text that it should be focusing on for analyzing in the prompt. So let's get to something a little bit more fun. For this, you will need to go to OpenAI's website. Oops. Create an account if you haven't already. So here, once you create an account, simply log in and you will be taken to an interface that allows you to extract your API keys. So once you get to this interface, on the left side panel menu, you will see these API keys. You click on here, you can create a new secret key, or you can just use one of your previous ones. As you can see here, I have a couple ones, and you can delete them, you can edit them. But here, create your new secret key, copy it, save it somewhere that you can refer back to, and let's go back to our Python. We're going to start by installing some dependencies. In this specific case, we're using LangChain. This is a package used for orchestrating LLM-based applications. And we're going to use this package to call our models, instantiate our models, and start creating templates for our prompts to be able to achieve much more complicated use cases. So let's start with this. I'm going to pass in my key right here. Here's where you will paste your own key. And LangChain is going to instantiate a ChatGPT, which is GPT 3.5 Turbo. This is the technical term of the model running ChatGPT, and a GPT-4. Now note that here we're using GPT-4 without having to pay the $20 per month, right? So the trade-off here is that instead of paying a monthly subscription, you will be paying for usage. So every time we use the models, there's going to be some cost associated with that, generation and input. And the cost usually is, you can see this in their website, but if you're using GPT-4, you will be spending around 0.003 cents per 1,000 words that you generate. So it's pretty cheap. It's pretty cheap to experiment with at low scale. So how do we run this? We have the models object, which in this case we call it ChatGPT for GPT 3.5. We're going to use the method invoke from this model and pass in the prompt. Same thing for GPT-4. In this case, remember the zero-shot prompt was about translating some English to French, and we can see the outputs of both models right here on Python on the interface. What's interesting is that there's a little bit of variation, and I think technically the correct response is this. So we can already see GPT-4 being a little bit more capable than ChatGPT. Let's try with the few-shot prompt that we have. Now the evaluation was the same one that we just tried, and the information that was extracted is pretty much the same thing. He learned a few things, made some friends, but he didn't like that it was disorganized, the professor was unprepared, and the reads were not helpful. We didn't need to paste anything into ChatGPT. Everything is done in this notebook itself, self-contained. Okay, so let's play with something a little bit more complicated, right? So far, we've been pretty nice to these ChatGPTs, to these LLMs. Let's set up a reasoning task. And chain of reasoning, not to be it's also somewhat of a variation of chain of thought, or this REACT prompt that stands for reason then act. It just involves presenting a problem that requires the model to follow a series of logical steps. So it's really just a particular case of a few-shot prompt in which the examples, instead of being examples of how this task has been solved in the past, the examples will be different types of problems and the reasoning that I've used or that I want the LLM to use for solving a specific task. So let's say we have the task description is solve the following math problems using step-by-step reasoning. And the examples are these two problems. If you have 3 apples and you get 2 more, how many apples do you have? Well, first you realize that you have 3 apples and you get 2 more. Therefore, you need to add 2 apples to the original 3 that you have, resulting in 5 apples, right? And then the second example is somewhat similar, illustrating this reasoning process. And now I have a new problem. The new problem would be a farmer has 17 sheep and all but 9 die. How many are left? Actually, this is what we did in the in-person workshop. Try to give yourself a minute here. What do you think? How many sheep are left? Are there 8, 9 left? Let me know. We're going to build our example string using the exact same method that we used before for few short prompts. And then we're concatenating them using F-string formatting in exactly the same way that we did for the few short prompts to create our chain of reasoning prompt. And this is what we get, right? Now, let's run it, see what each of these models have to say. ChatGPT says, obviously, very well following the reasoning process that we described the examples. It starts by saying, first, determine that the number of sheep that die by subtracting 9 from the total number of sheep is 17 minus 9 equals 8. Therefore, 8 sheep die, leaving 9 sheep remain. And GPT-4 says, well, just note that the problem says all but 9 die, which means that 9 sheep are still alive. So the farmer has 9 sheep left. This is the correct response. Now let's try running this a couple of times. Same prompt. I'm just going to run it a couple of times. See if we get anything different. Oops. Interesting. ChatGPT all of a sudden changed its response. Now it's saying first the farmer starts with 17 sheep. If all but 9 die, then you subtract 9 from the original 17, resulting in 8 sheep left. That is incorrect. While GPT-4 continued giving us the exact same answer by saying, hey, notice that it already give you the answer in the prompt by saying that all of them but 9 die. So we can already start seeing the differences in capabilities here. The larger model, GPT-4, is able to capture some more of the nuances of the text. Try using this at home, right? Pause the video for a little bit now and try to create your own chain of reasoning thought. Give it new math problems or give it some different types of problems that you might be dealing with in your daily life. You will be surprised that you can actually get these models to do many, many complicated tasks as long as you put enough effort, enough time into building the prompt. So this is why I meant that this is more of a collaboration than delegation of tasks. Because if you just say, hey, this is the problem, go ahead and solve it, you will most likely get a bad response, or a response that is not useful. Let's go through one more example. And this example is particularly useful in education. Let's say you're a student and your professor gives you a set of exercises and you were done with the exercises, but you're practicing for a midterm now and you would like to get more exercises of the like. of the type of exercise that your professor has been giving you. You can set up your professor's exercises as examples. In this case, we don't want to show the solution. We just want new examples, a new set of exercises to work on. And this is what we're setting up here. We have our task description, which are math problems from previous homework assignments across different topics. And I want the LLM to, based on these examples, generate a new set of math problems that involve similar concepts and complexities. I have three pairs of examples for statistics, calculus, and economics. I'm building my prompt and then appending each of the examples to this prompt. So this is a different way of building our few shot prompt, right? I just want to show you a different way we can go about doing the same construction. And then I'm defining two variables, two parameters for my prompt. The number of exercises and the subject that I want to generate exercises for. Print this out, here we get the prompt, and now let's run it with both models. Each of these, since it's a very straightforward task, there's no reason nor solution that they should be providing. Both models will work fairly fine, but they give different responses, different exercises. So I can now use this, go on and try to solve it myself and keep practicing for this exam. Now, this is the part where the recording came in touch because and as expected, we didn't cover this last example in detail. But I want to introduce it. It's going to be pretty advanced, but this is the holy grail right now in prompt engineering. RAG is called, it's a prompting technique, it stands for Retrieval Augmented Generation. And the main idea here is that if we have some relevant context that we would like the LLM to refer to when thinking through the task at hand, then we should be able to provide that. And if we provide it, we can augment the generation by retrieving the most relevant context of this specific information that you have at hand to help the model figure out the task. So what we're going to do here is I'm going to upload a PDF of my syllabus. To find it first. Wait 1 second. Here we go. I'm going to upload this PDF that is the syllabus of the class that I taught using LangChain all the time. LangChain has this object called PyPDF loader that uses a package called PyPDF in the background to load this PDF. Then I'm going to split it into chunks. Remember, we were working with this splitting of text. So I'm going to split it into chunks. And then I'm going to use what's called a vector store and an embeddings model. Remember that we were talking about embeddings model to capture this, the meaning, the context of the sentence, to encode each of these chunks and create documents from these chunks. I'm going to store those, index them in some vector store. In this case, is FIS, which is an open source vector store, vector database that was developed by Facebook or Meta. And then I'm going to instantiate a retriever. And this retriever is going to, based on some mathematical measure, in this case it's a similarity measure, which is simply the dot product between two vectors, between these two embeddings, is going to extract the top 3 most relevant chunks. So let's instantiate all these three, all of these components. And now we're going to define a prompt template. So LangChain abstracts the need for carefully constructing your prompts because it allows you to just build templates from them. And this is how it looks like. You build a template for messages, you pass in the list of tuples, just like we were doing before, but now you're using this same f-string formatting syntax without the f, because this is what LangChain is going to do in the background. It's just going to apply the f-string formatting to this template of string that you pass in. We're going to build a chain using the model, ChatGPT, and the prompt. I'm going to build 2 chains for each of the models. And finally, we instantiate some task prompts. Let's say we have a user query who's asking, some students asking, what are the learning outcomes of this class? For that, I'm going to retrieve the most relevant chunks of indexed documents. And by this, I mean, we're going to take the user query, create a vector out of that, and then we're going to check how similar is this user query to all the chunks that I've just embedded in the previous text, in the previous step. Using join, I'm going to create a context. So this is just a string. And I'm going to build a more general prompt that is called a system prompt to tell the model how to use this context and what is the task at hand that I want him to solve using this context. So I'm specifying using the following pieces of context to answer the user's question, maintain a conversational tone and try to be as helpful as possible, and always cite your source as the name of the file. And here I'm passing in the context, the metadata of the doc, which is the source, in this case it's going to be the name, and the user query. Let's do this, and let's actually print it out. And here we have it, right? It extracted this text. All of this is not in the prompt. It just got extracted by this retriever. It was extracted directly from my syllabus. And you can see all of this is the content of the syllabus. And it has the sources from which it pulled all of these three chunks, which is the same PDF. So therefore, it just prints the name of the PDF. And the user query, which is what are the learning outcomes of this class. So let's build the RAG prompt. And let's run the models. And let's see what the responses are. ChatGPT says the learning outcomes of this class are primarily focused on enabling students to grasp and engage with the material covered in upper division economic courses effectively. Through this course, students are encouraged to become proficient self-directed learnings, blah, 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 blah. All of this is text that you can find exactly on my syllabus. But GPT-4 gives us a much more structured response. And note that ChatGPT failed to give us the source that was specifically asked for in the prompt. While GPT-4 gives us a much better structured response, and it also cites the source as it was expected. So again, the more complicated the prompt becomes, the more nuance the model needs to take into account, the more important it is to use more capable models. Now, fortunately, there are many open source models that are pretty much at the level of GPT-4. So if you're comfortable with Python, I encourage you to check out Hugging Face or some of these open source repository of models. Using LangChain to access those models, because you can use LangChain to access both proprietary but also open source models, just try them out. If you can, you will most likely find a model that is free to use that works amazingly well for your specific use case or task. And here's one more example, just in case you want to play around with it, but I'll let you write the code for calling the models here. So I would say write code, call GPT-4 to solve task. Well, I forgot the caps. But anyways, this concludes our workshop. It was broad, but hopefully you got an idea of the main structures that we're working with here. So to recap, we're going to start with a simple and short prompt and then iterate from there. Remember the engineering cycle principles. You're going to clearly separate instructions from the text. Be specific and descriptive about the task and the desired outcome, right? If you have a specific format, a specific length or style that your text needs to be generated on, style could be some sort of active tone or poetry or something more technical, or like give me a paragraph format response or a bullet point format response, or the language. Remember to avoid ambiguous description and instructions, and always favor instructions to say what to do instead of those that say what not to do. Right? Just like we instructed little kids to learn how to hit the forehands and play some tennis, we wanted to keep it as clear and friendly as possible. So with that being said, that's everything I had for this workshop. I hope you found it useful. If you're interested in learning about any of these topics in further depth, or getting or working with the lab in any of our projects, then definitely reach out. Here's my LinkedIn and my email. I'm always happy to talk with people about these ideas. So with that being said, I hope you enjoy the workshop and I hope to hear back from you with some feedback. Thank you for coming.